Alright, so let's talk about bonds as if you had never seen a bond before in your life. What you want to think about, how you want to think about bonds is the following. Bonds have a payout rule. That payout rule is established by the issuer. So maybe it's the U.S. Treasury, maybe it's the City of Atlanta, maybe it's Coca-Cola. And that payout rule is going to have to tell you exactly when they pay. So our bond is going to make semi-annual payments, and it's got 5 years to maturity, and it has a $1,000 par and a 6% coupon rate. So let's put that in a box, and we'll look at it this way. We'll say, here is our payout rule, and we know the price of any financial asset is the present value of the future cash flows. So we need to know the size, timing, and risk of the cash flows. So let's look first at the timing and size of the cash flows. So the bond is issued today, and we will assume that the bond makes its first coupon payment in exactly 6 months. Now in reality, the bond is going to say it pays on particular days, like April 30th and October 31st, or maybe it's going to be May 31st and November 30th. So it will tell you those specific days in the document that tells you the rules. But for now, we're just going to say, all right, it pays, pick a date. It pays March 31st and September 30th, and today is September 30th. So it's going to pay in 6 months, in 1 year, a year and a half, 2 years, 2.5 years, 3 years, you know, let you fill this in, to 5 years. So if it has a $1,000 par and a 6% coupon rate, it's going to pay $30 every 6 months. So the payments are $30 every 6 months, and then at the end it pays $1,000. Now that $30 is because 6% coupon rate, 6% of 1,000 is 60, but it pays twice a year, so it's $30. So the price of any financial asset is the present value of the future expected cash flows. So I need to take the present value of each one of these cash flows, and they're going to be a total of 10 of them. You know, this will be 30 times 1 plus y to the 9th, and then this is 1,030 times 1 plus y to the 10th. So the question now is, what is y equal to? So remember what you need to know with valuing any cash flow stream. You need to know the size, timing, and risk of the cash flows. Well, we have here the size and the timing of the cash flows. Y is going to tell us the risk of those cash flows. So we as the investor determine how much risk we think is in the asset. We determine the real return that we need, the inflation premium that we need. So this is a number that we determine, and this changes. The payout rule doesn't change. The only thing that changes in the payout rule is the time to maturity, and it changes as time goes by. So let's say in this example, we're going to call Y, we're going to say we need to have a yield to maturity. And I always want to have that yield to maturity in annual terms. It's an interest rate, and so a rate has to be in a certain time frame. I'm going to say that rate is in years, so I'll quote it and say that's 6.2%. But that's an annual rate. So my Y, because these are semi-annual payments, is going to be half of 6.2%, which is going to be 3.1%. So the price is going to be 30 divided by 1.031 to the first, plus 30 over 1.031 squared, plus to all of these 30 over 1.031 to the 9th, plus 1,030 1.031 to the 10th. Alright, so it's going to take you a long time to do that, right? So that's why you have the financial calculator. Financial calculator, you say how many payments are there? There are 10. What are those payments equal to? They're equal to $30. What's the future value? Future value is equal to 1,000. So that we have right here, that's the payout rule. And we get that payout rule from what the bond issuer says. They tell you that. So then I put in for my interest rate 3.1%, and putting all this into my calculator, pressing the present value key, it's going to give you a present value of $991.51, and it will give you that as a negative number. Don't worry about that for now. It's just saying that's the cost, so that's what you would be paying. Alright, so I want to look at a couple little details here. So let's say time goes by. So I said what changes, and this is yield to maturity. So let's say the yield to maturity is now 4 years because time has gone by. So this has been paid, this has been paid. So this is now 6 months. This is now a year and a half. This is now a year. This is a year and a half. This is 2 years. And that goes up to 4 years. So in other words, what we have now is n equal to 8. The payment is the same, $30. The future value is the same, 1,000. And I'm going to say the yield stayed the same. Now this could change, right? This is subject to market conditions. But I want to show a point here. What if it stays the same? When I put in all this into the calculator and I hit the present value key, do you think this number is going to be higher or lower than 991.51? And this is how we know which it's going to be. It's going to be higher because all bond prices tend toward 1,000. Alright, so as we go through time, the price tends toward 1,000, and sure enough it comes out to be 993.51. Now notice both of these bond prices are below 1,000. Why is that? Because the required yield of 6.2%, required yield of 6.2% is more than the coupon rate of 6%. We know if the yield to maturity and the coupon rate are equal, then the bond sells for par. If interest rates go up, bond prices go down. Now look at why. If the denominator is bigger, what happens to the ratio? The price goes down. Right? So you want to know that rule. If yields go down, bond prices go up. Yields go up, bond prices go down. Alright, so let's look at this from a slightly different setup. So let me move this up a little bit, and we want to come up with a new payout rule. And let's say that we have the same payout rule, actually 5 years to maturity, semi-annual pay, 6% coupon. But now I want to say the yield to maturity is 5.8%. So everything is the same. N's equal to 10. Payment is equal to 30. Future value is equal to 1,000. The interest rate is 5.8 divided by 2. Plug all the in. It's going to be present value. That present value is going to be higher or lower than 1,000. Well, the yield is below the coupon. So interest rates went down, bond prices went up, so this has to be more than 1,000, and sure enough it comes out to be 1,008.57. Alright, so again, let's say that time goes by. So now a year goes by, we have 4 years to maturity. Let's say yields stay the same. So all we change is this is going to be equal to 8. Everything else is the same. The new present values are going to be higher or lower than the old. Bond prices tend to 1,000. It's going to go down to 1,705. Alright, so that's kind of the beginning of bond pricing. This is the most basic bond pricing we've done right there. I want to show you a couple of different things here. So let's say we have a 2-year 5% coupon. Once again, semi-annual pay bond. Par is equal to 1,000. So the price is going to be equal to the future cash flows, the present value of the future cash flows. It's 25, 25, 25, 1,025. Right, but what we want to show next is that you don't, in reality, you don't discount all those payments at the same yield to maturity. When we talked about the yield curve, we said each time period has its own unique interest rate. So in other words, when we say present value is equal to future value over 1 plus r to the t, I can really put a little subscript on that r and say every time period is going to be different. So this bond is really, think of it as four, this thing going to be a good circle. Think of it as four, as 1, 2, 3, 4 different payments, right? So I need to have an interest rate. I'm going to call it Z1 here. I'm going to call this Z2. I'm going to call this Z3 and call this Z4. So I need to find an interest rate that's associated with those times, because this is time 1, time 2, time 3, time 4. So the question is, how do I do that? Well, we can go and we can find, zero coupon bonds and find their maturity. So we have one that matures in 6 months, maturity in years. So this is 6 months, 1 year, year and a half, 2 years. Let's find their price. And the price is $980, $950, $910, $870. Once again, these are all zero coupon bonds, so they all follow this equation. So I can say 980 is equal to 1,000 over 1 plus Z1. Why is this true? The present value, the price, is equal to the future value. It just pays you par of $1,000 because it's zero coupon. And when I discount at 1 plus at interest rate Z, I'm trying to find that rate. When I do that, I find Z is equal to 2.041%. Alright, now I know the semi-annual compounding and annual compounding can be a little confusing. But what I've done, this is 6 months, so this is a semi-annual rate. So if I were to tell you what the spot rate is, I would say in terms of 1 year spot rate is 4.082%, which is double that, right? So what I have over here is, if Z1 is equal to 2.04%, that's 1.02041, and now I need to find Z2, Z3, Z4. Do this the same way. 950 is equal to 1,000 over 1 plus Z2 squared. Z2 is equal to 2.598%. So R2 is equal to 5.196%. Alright, so if the algebra confuses you, go to Khan Academy and look up some algebra stuff, or come talk to me. But anyway, I want you to understand the point of this, and the point, once again, to hammer it home. I'm looking at this bond as 4 separate bonds. So when I follow the fundamental principle of valuation, I say I want the price to be the present value of the expected future cash flows. Well, the 4 separate cash flows occur at 4 different times, so I need 4 different interest rates. So I can look in the market, I can see this is what's currently out there. So currently in the market there is a 6-month bond that pays nothing until the 6 months is up. It makes one payment it costs $980. Because it just makes the one payment, I can use this equation right here. Present value equals future value over 1 plus r to the t. There's another zero coupon bond that costs $950 and it will pay you $1,000 in a year. A third one that costs $910 and it will pay you $1,000 in a year and a half. And the last one it costs $870 and will pay you $1,000 in 2 years. So using this information, I can find what the market interest rates are for the bond that matures in 6 months, 1 year, year and a half, 2 years. So I'm doing the same math here each time, and this is going to be 25 divided by 1.025986 squared, plus I'm going to go ahead and give you the answers. 25 divided by 1.03194 cubed plus 1025 divided by 1.03543 to the fourth. So where did I get these numbers? I got those numbers by solving the equation 910 equals 1,000 over 1 plus z3, and that's cubed, and also solving 870 equals 1,000 over 1 plus z4 to the fourth. So when I solve this, I get the price of $962.75. Alright, so this is how it works in reality. I've found that the price is $962.75 by finding the size and timing of the cash flows, the 25, 25, 25, and 1,025 from the payout rule that I'm given. And then I find these interest rates. This is what the current market rates are for those 4 separate payments. So the yield curve here is upward sloping, right? Because the yields get larger each time. But if I'm a bond trader, it's convenient to talk about the price of a bond in terms of yields. That's true because yield gives me one number. So the yield to maturity solves this equation. Now the price of $962.75 is equal to 25 over 1 plus y plus 25 over 1 plus y squared plus 25 over 1 plus y cubed plus 1,025 over 1 plus y to the fourth. So what yield to maturity is telling you is once you discount the future cash flows at their unique interest rates and find a price, then tell me a y that makes that equation stay true. So if I discount each one of these cash flows at some y, what would that y be to make the price stay the same? So here we can just say, you can't solve this by hand, by the way. That's what the calculator is for. I mean, it would literally take you probably days to get this exactly right. N's equal to 4. Payment is equal to 25. Future value is equal to 1,000. That's the payout rule. The price I paid for it would be $962.75. I plug all that in, and IY comes out. My yield to maturity is the IY times 2. And I didn't write down IY, I just wrote down what it was times 2, which is 7.029%. So the yield to maturity is, in a sense, the average of these interest rates. Alright. So, last thing. I want you to really, truly understand, not have those steps memorized, and not just be able to repeat them on a test. But I want you to really understand each one of those concepts. So if there's anything in this video that is not abundantly, perfectly, exceedingly clear, please let me know. Let's talk through it on the phone or email or next Thursday night. But this stuff is foundational, and to move forward you have to understand every bit of it. Alright, so I'll see you next Thursday, or talk to you before then.